Yeah. Good evening, children. Good evening, online students.
Good evening, ma'am.
Good evening, ma'am.
Yeah.
Good evening, ma'am.
Good evening, children. Good evening. Yeah, so we'll see the answers to the homework questions. Yeah, what's the answer for the first one? Yes, quick. Perfect. 3√3 minus 3√2 by Sasmati. Very good. 3√3 minus 3√2 is the answer for the first one. Good. Just send the pictures on WhatsApp in the group. Yeah, second answer, Surya. Correct. 4√2. 4√2 plus 2√3. Perfect. Surya, very good. 4√2 plus 2√3. The answer for the second one. Acknowledge online students.
Yes, ma'am. Got the same answer.
Very good.
Got it.
Yeah. Question number
Yes,
1,
ma'am.
third subdivision. Online. Someone online, tell me. Third answer.
Ma'am, I got √2 plus 8√3 minus 6√5.
Perfect. Square root of 2 plus 8√3 minus 6√5. Even I have the same solution. Yeah, the fourth subdivision. Yeah, Sanspriti. Correct. √7 plus √2 plus 5√11. √7 plus √2 plus 5√11. Correct? Yeah. So you had asked me on WhatsApp, right? You had sent a voice note regarding this question. It's my, I did not look at the question. You just said it's given by. So I said, do as directed. Multiply. No, the main heading is multiply 3√5 by, see, multiply 2 by 3. What would it do? 2 into 3, right? Yeah, I think you were confused with the word by. Disable your mic. I think you were confused with the word by. No, multiply 3√5 by 2√5. Or multiply 3√5 and 2√5. And one more thing, the heading is there now, multiply. Yeah. Multiply. So you'll have to. Okay, then. Yeah. Question number 2, first subdivision, answer.
Ma'am, I got 30 for the first question.
Correct. 30. Correct. Second subdivision.
165.
165. 165. Correct?
Yeah, ma'am.
Correct. Next one. 72.
4√45.
72√5.
72√5. Shreya, 45 can be factorized as 3 into 3 into 5. 45 is 3 into 3 into 5.
Oh, okay, ma'am.
So from 2 3s, 1 3 out of the square root. So it's 72√5.
Okay, ma'am.
Yeah, next one. 80. 18 root 2. Very good. 18 root 2. Next one. 36. 36. Next one. 20.
20.
Next. Yeah, next answer. Question number 2, 7 subdivision.
84.
84.
84. Correct. Then question number 3, first subdivision, divide.
4 root 3.
4 root 3. Very good. Very good. 4 root 3. Very good. Second one.
5 root
5 root 3.
5 root 3. Very good. Whether you're all not excited or not, I'm very excited. Yeah, third one.
3 root 5.
3 root 5.
3 root 5. Very good. Yeah, next one.
3 root 3.
3 root 3.
3 root 3. 3 root 3. Yeah, next one. Okay, then next is examine whether the following numbers are rational or irrational, right? Yeah. So you need to simplify them and then decide. We're not supposed to just, like we judge food, you eat with your eyes first and then you actually eat it, right? You look at the presentation. No, this is not going to be tasty. Some of us, not all of us at least. Okay. So we just eat. So we eat food. Some of us eat food with our eyes, you look at it and you're like, you decide whether we don't decide if it's healthy or not, we decide if it's going to be tasty or not. And you eat first with your eyes and then you say, no, I don't want it. So like that is wrong. This is also wrong. You should not look at the expressions, oh, there is a square root symbol, so it is irrational. Okay, this does not have a square root symbol, so it is rational. It's not like that. You have to simplify. Like you eat and then say it's tasty, it's nutritious. Like that you work, you simplify, and then you decide whether it is rational or irrational. Yeah, the first one. On simplifying, what's the answer? 20. On simplifying, we're talking about question number 4, first subdivision. Upon simplifying using the identity a minus b into a plus b is equal to a squared minus b squared. Upon simplifying using this identity, we get 20. The value of the given expression is 20. So 20 is rational. So the given expression is rational. 20 is rational. So the given expression is rational. Second one.
7 plus 4 root 3.
Rational?
Question number 4, second subdivision. Again, others online.
I got 7
No,
plus 4
7
root
plus
3.
4 root 3. 7 plus 4 root 3.
You same. Same, ma'am.
Okay. Surya, you have a different answer, Surya? 6 you got, is it? 2 AB is 2 into root 3 into 2, right? 2 into root 3 into 2. The 2AB term is 2 into root 3 into 2. So 2 into 2, 4 root 3, right? So you have written that as 6 root 3? Yeah. So you are right, but you've gone wrong in the multiplication part. Yeah, third subdivision. Yeah, I don't know if I announced the answer for this one. So the answer for question number 4, second subdivision is 7 plus 4 root 3. 7 plus 4 root 3. Yeah, next one, third one. Minus 1 by 3. So here children have got minus 1 by 3. Online? Children online, please share your answer.
Ma'am, same answer.
Same answer.
Yes, ma'am, same answer.
Okay. So you all got minus 1 by 3. Minus 1 by 3, right? That's the correct answer. Minus 1 by 3 is the correct answer. Yeah. Question number 4, fourth subdivision. 12 root 2. Here offline students say 12 root 2.
Same answer.
Same
Very
answer,
good.
ma'am.
Very good. Yeah. Question number 5, first subdivision. Four root 6 plus. Oh, I have an answer with 4 terms. Yeah, what's the answer for question number 5, first subdivision?
Mom, I got it as 18 plus 12 root 2 plus 6 root 3 plus 4 root 6.
Yeah. So even I have the same solution. 18 plus 12 root 2 plus 6 root 3 plus 4 root 6. Okay, we'll see that. Yeah, then the second subdivision.
4 root 5 plus 5 root
4 root 5 plus.
5 root 2.
Correct. 4 root 5 plus 5 root 2. No? You have a doubt with the second subdivision. Okay. You haven't completed. Okay. Okay. Okay, the answer is 4 root 5 plus 5 root 2. Question number 5, second subdivision. The answer is 4 root 5 plus 5 root 2. 4 root 5 plus 5 root 2. Okay. The third one. No. Maybe you have to simplify it still further. We'll see. Yeah, online students, answer for the third subdivision. Question number 5.
Mom, minus 2 root 5 by 3.
Yeah, even I have the same answer. Minus 2 root 5 by 3. Minus 2 root 5 by 3. Yeah. What subdivision? What
Ma'am, I got
subdivision?
the answer. Ma'am, I got the answer as 23 root 2, ma'am.
23 root 2. Correct. Others?
Same answer.
Okay.
Same answer.
All right. Fifth subdivision?
Ma'am, I got 11 minus 6 root 3.
Different answer.
Ma'am, I got it as minus 61 minus 17 root 14.
Okay. Correct. Even I have the same answer. Lakshana and Sai Smriti. Minus 61 minus 17 root 14 or minus 17 root 14 minus 61. Correct. Sixth one. $30. Sixth subdivision, 30. Seventh one, 3. 7, 3. Eight. Okay. Online students?
5 plus 2 root 6.
5 plus 2 root 6. Correct. I too have the same solution. Very good. It's nice that all of you have almost completed the homework. Very good. I come to that conclusion with the participation I saw. Most of you were giving out your answers, except for Aishwarya. I just assume you have some mic issues. I'll just share my screen. Yeah, online students, I've shared my screen. Visible to all of you?
Yes, ma'am.
Yes, ma'am.
Okay,
Ma'am, it's visible.
very good. Yeah. I'll just present all the answers so that in case you use a recording, while I was recording, while we were discussing the answers, I hadn't shared my screen. So the recording wouldn't have captured. So I'll just take you through the slides again so that in case you use the recording, you can find the answers here also. I've shared all the answers on WhatsApp. So I want you to go through the answers which you were not able to try by yourselves. You should be able to understand with the steps, just in case you have a doubt with any answer, you can ask me in the next class on Friday. So you make a note of it and ask me. That should be the first thing you do on Friday. Because as you can see, I have worked it with the steps. So you should be able to check your answer with, what I've shared on WhatsApp, and you should be able to compare and find out if you've gone wrong somewhere, because we've already discussed the concept earlier. If you still have trouble in understanding, mark your doubts and make sure you get them clarified in the beginning of Friday's class, not at the end of the class, please. So this is the end of the answers to the homework questions, right? Yeah, now open your notebook, take down this question. Yeah. So in this question, since you see 72 happening 2 times, just a guess. You can see square root of 72 in the numerator. No, the connecting signs are plus and minus, so we cannot cancel like that. So we have square root of 72 in the numerator and the denominator. So you can just check if 288 and 648 are multiples of 72. Please check that first and let me know. Check if these two numbers are multiples of 72. Take down the question and divide and divide and let me know.
Yes, ma'am, they are.
Yes.
Yeah.
So square root of 72 divided by 5 root 72 plus 3 square root of 288 minus 2 square root of 648 is equal to, we'll write the square root of 72 as it is by 5 root 72 plus how many times 72 is 288?
4.
4, is it? 4 times. Okay, so 4 into 72 or 72 into 4? Yeah. So 72 4 times, right? So 4 into 72 or 72 into 4, whatever. And then 648, 9 times. Very good. So 9 into 72. Next step, write square root of 72 as it is, divided by 5 root 72 plus, now there is 4 under the square root. So it comes out as 2 because square root of 4 is 2, right? Square root of 4 is 2. So there's already 3 there and square root of 4 is 2. So it comes, 4 comes out of the square root as 2, but 72 remains under the square root. Minus 2, 9 comes out of the square root as 3 because square root of 9 is 3, right? And 72 remains under the square root. Right. So next step, square root of 72 divided by 5 square root of 72 plus 6, because 3 to the 6. 6 square root of 72 minus again 3 to the 6. 6 square root of 72. Now these are the same terms, no? Plus 6 square root of 72 minus 6 square root of 72. So they get cancelled. So you're left with what? 72. So now you can cancel. It's like x by, or you can say y by xy. So you can cancel y and y. Square root of 72 divided by 5 into square root of 72. That's the meaning. So you can cancel square root of 72, the numerator and denominator. So the answer is 1 by 5. All right? Very good. Write down. Please write down, children. Done, children? Yeah.
Done, ma'am.
Very good. Why Shriya and Yarni online? Gayatri also.
My mom must be checking something, ma'am. I don't know.
Gayatri and Yarni.
Ma'am, I got sick today, ma'am, so I had to stay. I'm sorry.
My mom was today, so she can't.
Oh, because, ma'am, actually, that's because the driver actually was not present today, so that's why.
Okay. All right. Done writing? Finished? Same thing, no? What we did earlier is what you can see here also, right? Okay, next one. Take down the question, children. Oh my goodness, what's happening? Yeah. All right. So don't write down, don't write anything. Have you taken on the question? No, right? No, please wait, please wait. Let's just discuss the answer and then you can do it. Okay, so you can see the two terms are connected by the division symbol, right? So we'll write the first term as it is, square root of a square minus b square plus a divided by square root of a square plus b square plus b. All right, now division becomes multiplication and you need to take the reciprocal of the second term. So second term, the denominator becomes a numerator. Reciprocal, no? The numerator becomes a denominator. Reciprocal of the second term. So we have this, right? Now you cannot cancel because you can see there is plus minus signs in the middle. So we cannot cancel anything like. Which one? A square minus b square. No, we'll not expand. We'll see what we can do. All right. Now you can see the numerator. You can see that in the numerator we have the same terms. Can you see here a and a here? And can you see square root of a square minus b square? Square root of a square minus b square. You have the same terms. Now, if we rearrange, look at this. If we rearrange the terms here, this numerator, no? If I write this as a plus square root of a square minus b square. Look at the numerator given in the question and what we have written here. It was given like this in this order. Square root of a square minus b square plus a. We know that addition is commutative, right? 3 plus 4 is equal to 4 plus 3. So you just write it the other way. So a plus square root of a square minus b square. See, there's a plus sign in the middle, right? So you write this one first and then you write this. You're not changing the value, right? Okay. Now you see the numerator. You have a plus square root of a square minus b square, a minus square root of a square minus b square. You have the same terms, like it's in the form x plus y into x minus y. So it's x square minus y square, the numerator. And the denominator also. See here, the terms are the same. Here, you can look at this as x, this one as x, and this one as y. All right, so we have x plus y and x minus y. So when you have to multiply two fractions like this, how do you multiply? Like, see, you have 2 by 3 into 7 by 11. How do you multiply? Multiply the numerators and multiply the denominators, correct? That's how we multiply. We don't take LCM for multiplication. Only addition, subtraction is simplified using LCM. Yeah, so when it's multiplication, we multiply the numerators, multiply the denominators. So 2 7s are 14, 3 into 11 is 33. So we'll have to multiply the numerators here, multiply the denominators. Now the numerators, both the numerators and the denominators, they are of the form x plus y into x minus y. So the product is x square minus y square. The product is x square minus y square. See, in the numerator, this is x. This is x in the numerator. You can see the plus sign here, minus sign here. And this one is the y term. This is the y term. It's the same. See, both are the same. Here also, this is plus, this is minus. The terms are the same. X plus y into x minus y. So the product is x square. Next step, we write the product. When you multiply the numerators, which are of the form x plus y into x minus y, what's the product? X square minus y square. So x square, which is a. X is a. So x square minus is because in the identity we have minus. X square minus y square. So we need to write y here. Square root of a square minus b square. This is y square. Divided by, again, same identity in the denominator. X plus y into x minus y is x square. What is x? This is x. This one is x in the denominator. This is x. X square minus y square. This is y. Y square. Correct? So now a square minus, see, when you have square root of 5, the whole square, it's like the square and the square root, they get cancelled. So the answer is 5. The answer is 5. Because what is square root of 5, the whole square? It is square root of 5 into square root of 5. square root of 5, the whole square, we know this. So square root of 5, the whole square means square root of 5 into square root of 5, correct? So the square root of 5 into 5, so which is 5. In the same way, see, square root of 5, the whole square. What is the answer? 5. In the same way, square root of a square minus b square, the whole square. So here what happens? This one and this one gets cancelled. The answer is 5, no? So here also the square and square will get cancelled. The answer is a square minus b square. A square minus b square. Okay, so a square minus, you should write that in the bracket, a square minus b square, because we have a minus sign here. So in the bracket, a square minus b square divided by, what's the answer here? Plus b square minus b square, correct? So that is a square. Now open the bracket, minus a square plus b square, because minus a square, minus into minus plus b square divided by, now here in the denominator, plus b square minus b square gets cancelled. So we have a square here. In the numerator, a square minus a square gets cancelled. So the answer is b square by, this is the result. All right. Right on.
Done, ma'am.
Good. Yeah.
Mom,
Yeah.
I have a doubt, mom. Shouldn't we cancel numerator and denominator?
No, when the terms are connected by a plus or a minus sign, you cannot cancel. No, you know it actually. See here. See, supposing you have 4 plus 3 by 4 minus 3. Will you cancel 4 and 4, 3 and 3? No, right? So the answer is actually 4 plus 3, 7 by 4 minus 3, 1, which is 7. But if it is 4 into 3 by something like 4 into 7, then you can cancel 4 and 4.
Okay, mom.
Okay, B by A the whole square. Okay.
Completed, mom.
Very good. All right. I've written the question again, and the answer is equal to B square by A square. Finished? Finished? Okay, you can finish it yourself, right?
Mom, what are you speaking of?
Thank you. I think that was Gayatri. Thank you, Gayatri. Yes. Okay, I'll repeat. So I was saying, we have learned how to simplify operations with real numbers. Okay, how to perform operations with real numbers, how to add, subtract, multiply, and divide two real numbers, two or more real numbers. Okay, so the next concept is rationalization. Now, what is rationalization? We'll just take an example. Consider this number 1 by root 2. Am I audible, online students?
Yes, mom.
Yeah. Now consider this number. So at this point, we have understood how to simplify operations with real numbers. Correct, children? The assignment, with the assignment, it's very clear. Yes or no? Very good. Very good. All right. So the next concept is rationalization. Now, to understand what is rationalization, we'll take an example. Look at this number 1 by root 2. Clearly, the denominator root 2 is irrational. The denominator root 2 is irrational. Now, we'll see how to rationalize the denominator. The denominator of this number 1 by root 2 is irrational. Now, we're going to perform a procedure and make the irrational denominator rational. Okay, see the procedure. So what we'll do, we'll multiply and divide by root 2. We have learned equivalent fractions, right? See, when you're given in class 4, your teacher will give you a fraction like 3 by 7. And she'll say, write 4 equivalent fractions to 3 by 7. So what you'll do with your little hands, you would have done this, no? Into 2 by 2, 6 by 14. Yes or no? Then 3 by 7 into 3 by 3, 9 by 21. Then 3 by 7 into 4 by 4. Able to recall or no? 12 by 28. Same thing here. When you multiply and divide by the same number, it's like you're multiplying by 1. You're multiplying by 1. You're not changing the value. See, you're given the number 1 by root 2. The denominator is irrational. You want to rationalize the denominator. You want to make the irrational denominator look rational. And the procedure is you're multiplying the numerator and denominator by root 2. Now, why root 2? I have not explained. I'm just showing you the procedure. I haven't explained why root 2. I'll tell you that. So you can multiply the numerator and denominator by root 2. Now, by doing so, you are not changing the value of 1 by root 2 because the net effect is you're multiplying by 1. The net effect is you're multiplying by 1. So you're not changing the value. Right? Okay. So now what happens? The given number is 1 by root 2. So you multiply and divide by root 2. So what happens? 1 into root 2. 1 into root 2 is root 2. 1 into root 2 is root 2. By root 2 into 2, root 2 into root 2 is 2. Now see, the numerator has become irrational. The denominator is rational. In this process, the value of the given number will be the same. 1 by root 2 is the same as root 2 by 2. Because we have just written an equivalent number. We have just written an equivalent number by multiplying the numerator and denominator by root 2. That's all, like writing equivalent fractions. See it again. 1 by root 2 is the given number. Denominator is irrational. We multiply and divide by root 2. It's like writing an equivalent number. Okay, so you're multiplying by 1. You're not changing the value of the given number. So multiply the numerators, root 2, by multiply the denominators. Root 2 into root 2 is 2. Now look at the denominator, 2 it is. What was the denominator in the number given? Root 2. Root 2 is irrational. But now see the denominator is 2, which is rational. However, the value of the number given 1 by root 2 and the value you have now got, both are the same. They're equivalent numbers. Because how did you get this new number? By multiplying and dividing by root 2 by 1. So you've written an equivalent number and that equivalent number has a rational denominator. The given number has an irrational denominator. the equivalent number has a rational denominator. So this is the process of rationalizing the denominator. So what did we do? When you're given a number, so this is the definition of rationalization, or this is the understanding of rationalization. So when you're given a number, okay, with an irrational denominator, the process of rationalizing the denominator, the process of making the denominator, I shouldn't use the term rationalizing. So the process of making the denominator rational, the denominator of the given number is irrational. The process of making this denominator rational, how? By multiplying the number, by multiplying the numerator and the denominator by the same number is called rationalization. It's called rationalization. You're given a number with an irrational denominator. Okay, so you multiply the numerator and the denominator of this number by a particular number, and you change the irrational denominator to a rational denominator. This process is called rationalization. All right. So the process of converting the denominator, that each denominator, okay, let me read from the beginning. So supposing we are given a number whose denominator is irrational, then the process of converting its denominator to a rational number by multiplying its numerator and denominator by a suitable number is called rationalization. All right. Now, what is a rationalizing factor? Now, let me just use the definition of reciprocals to explain what rationalizing factor is. Now, when the product of two numbers is 1, then we say that the numbers are reciprocals of one another, right? Now, say 3 by 7 and 7 by 3. What's the product of these two numbers? 3 by 7 and 7 by 3. What's the product? 1. So, yeah. So when the product of two numbers is 1, then the two numbers are reciprocals of one another. When the product of two numbers is 1, then the two numbers are reciprocals of one another. In the same way, when the product of two irrationals is rational, when the product of two irrationals is rational, then each irrational is said to be the rationalizing factor or the conjugate of the other. So see here, if the product of two irrational numbers is rational, then each one is called the rationalizing factor or the conjugate of the other. So you can just use the definition of reciprocals to understand this. I'll come again with this. So like 2 by 3. What is the reciprocal of 2 by 3? 3 by 2. 3 by 2. So in this case, the product of this number and it's the product of these two numbers is 1, right? The product of these two numbers is 1. When the product of the two numbers is 1, we say that the numbers are reciprocals of one another. 2 by 3 is the reciprocal of 3 by 2. 3 by 2 is the reciprocal of 2 by 3. In the same way, when the product of two irrational numbers is rational, when the product of two irrational numbers is rational, then each number, okay, is called the rationalizing factor or the conjugate of the other. Each number is called the rationalizing factor or the conjugate of the other. Now, for example, in this one which we just took, root 2, its rationalizing factor is root 2. The rationalizing factor of root 2 is root 2. The rationalizing factor of something that looks like root x plus root y is root x minus root y. The rationalizing factor of root x minus root y is root x plus root y. So you can see here, the rationalizing factor of a plus or minus root b. A plus or minus root b meaning 3 plus or minus root 5. Something like this. A plus or minus root b. That is, A is rational. Root b is irrational. But the whole thing is irrational. Okay, an example for this is 3 plus root 5. The rationalizing factor of 3 plus root 5 is 3 minus root 5. And the rationalizing factor of 3 minus root 5 is 3 plus root 5. Why? Because when you multiply these two, no, the answer will be rational. When you multiply these two, see, this is irrational. This is also irrational. But the product of these two irrationals will give you a rational number. So they are the conjugates of one another, or they are the rationalizing factors of each other. Now, an example for this one. See, how do you read this? A plus or minus root B is A minus or plus root B. Because if it's plus, it will be minus. If it's minus, it is plus. The rationalizing factor of A plus or minus root B is A. If it is plus, it will be minus. If it's minus, it will be plus root B. Then, look at this one. The rationalizing factor of A plus or minus B root X is A minus or plus B root X. Okay, so example, say 5 minus 7 root 3. So this is like A minus B root X. So you just compare A plus B root X, A minus this one, A minus B root X, 5 minus 7 root 3. What will be the rationalizing factor? 5 plus 7 root 3. So if this is say like 2 minus 5 root 7, or I'll put a plus here, then it will be 2. Okay, so this one is a rationalizing factor of this one, and this one is a rationalizing factor of this one. This one is a rationalizing factor of this one, and this one is a rationalizing factor of this one. Because these two are irrationals. This one is irrational, this one is also irrational, and the product of these two irrationals will be rational. So they are conjugates of one another, or rationalizing factors of each other. And the last one, root x plus or minus root y. The rationalizing factor of root x plus or minus root y is root x minus or plus root y. All right. So example, supposing root 2 plus root 3. The rationalizing factor is root 2 minus root 3. If it's root 10 minus root 3, then it will be root 10 plus root 3. All right. Now, okay. And one more thing is the rationalizing factor should be the simplest number. Okay, rationalizing factor should be the simplest number. Now, to explain what I mean, I'll give you a question. You answer it. You may get it right. Okay. So whether you get it right or you go wrong, with the help of that example, I'll be able to explain what a rationalizing factor, what I mean by the simplest form of a rationalizing factor. So now, what is the rationalizing factor of 1 by root 8? What is it's simple question. What is the rationalizing factor of 1 by root 8? See, like for 1 by root 2, what did we say? 1 by root 2, what's the rationalizing factor? Root 2. Root 2. Because we have to multiply and divide by root 2, right? And this root 2 and root 2 is 2. The product of these two irrationals is rational, 2. So the rationalizing factor of the denominator here, root 2, is root 2 only. So what's the answer for this one?
Root 8 by
Root
8 by 8. Root 8 by 8.
So we'll have to multiply and divide by root 8, correct? We'll have to multiply and divide by root 8, correct? Because what did we do for 1 by root 2? We multiplied and divided by root 2. So applying the same thing here, it will be multiply and divide by root 8, correct? But no, that's not the answer. Because now this surd root 8 can be expressed as a mixed surd. Look at this. Okay. So whenever you can express the denominator as a mixed surd. So see the simplification. Do you all agree? The given question or the given number 1 by root 8 is nothing but 1 by 2 root 2. Agree? Because root 8 is root of 2 into 2 into 2. And from 2 2's, 1 2 comes out as a square root. So the given question or the given number 1 by root 8 is nothing but 1 by 2 root 2. Correct? Now, 1 by 2 root 2 means 1 by 2 into root 2, where 2 into root 2, where 2 is already rational. So which is irrational? See, when it is 2 plus root 2, this is one whole thing. You cannot look at 2 separately and root 2 separately. When they're connected by the plus or minus sign, see, when it is 2 plus root 2, it's 1 unit. 2 plus root 2 is 1 unit. So the rationalizing factor is 2 minus root 2. When they're connected by plus or minus sign, look at them as 1 unit. The rationalizing, now in 2 plus root 2, you cannot say 2 is rational, so I'm going to rationalize only root 2. No. Because 2 plus root 2 is 1 unit. They're connected by the plus sign. But in 2 root 2, it's multiplication. So you can see them separately. 2 root 2 separately. Wherein 2 is rational. It's already rational. Then what are you going to rationalize again? You will rationalize something which is irrational. Excuse me. One second. I'll ask you. Yeah. So we are talking about the difference between 2 plus root 2 or 2 minus root 2 and 2 root 2. We're trying to understand the difference between these three numbers. 2 plus root 2 is 1 unit. So its rationalizing factor will be 2 minus root 2 or its conjugate will be 2 minus root 2. 2 minus root 2 is 1 unit because it's separate. 2 and root 2 are connected by the minus sign. So it's 1 unit. So its conjugate or rationalizing factor will be 2 plus root 2. But in 2 root 2, 2 and root 2, they are connected by the multiplication sign. So you can look at them separately. 2 different, root 2 different. And what's the idea? What's the concept? Rationalization. What do we mean by that, or what are we doing here? If the denominator is irrational, we'll rationalize it. Now, if the denominator is 2 root 2, 2 is already rational. Now, what are you going to do again? Rationalize that? No, right? So you'll take only the irrational part. The irrational part is root 2. So you have to just multiply and divide by root 2 to rationalize the denominator. So when it is 1 by root 8, when it's 1 by root 8, always, whenever you can, so this one is called a pure surd. Root 8 is called a pure surd. If you can express it as a mixed surd, it's mixed form. Or when you write root 8 as a mixed surd, it is 2 root 2 as a mixed surd. Root 8 is a pure surd. That means it's like there's a 1 before it. Then it's a pure surd. If it's not a 1 before it, it's a mixed surd. That's all. If there's a 1 before it, it's a pure surd. Not it's something other than 1 before it, it's a mixed surd. That's all. That's enough. All right. So if you can express the denominator as a mixed surd, not all denominators can be expressed as a mixed surd. Now, supposing you have say like 3 by root 15. Okay, you can write root 15 as root of 3 into 5. You can write root 15 as root of 3 into 5, but there's only 1 3 and 1 5. So you cannot bring any of them out of the square root. 15 is 3 into 5, but under the square root, you have only 1 3 and 1 5. So nothing, no point. You have to again put them back as root 15. Not every surd can be expressed as a mixed surd. Only when you see, like you break down the number into its factors and you find pairs of equal factors. Only when you find pairs of equal factors, rend 2, rend 3, rend 5, you need to find pairs of equal factors. Only then you can express it as a mixed surd. Not always you can do. You can try, but if it's not possible, leave it. So in the case of root 15, it's not possible to write root 15 as a mixed surd. So you should always look at the denominator. That is, if this is also a part of simplification. Okay, so writing the denominator as a mixed surd is also simplifying. Okay, so 1 as it is, root 8 is nothing but root of 2 into 2 into 2. So which simplifies to 1 by 2 root 2. Because from 2 2s, 1 2 out of the square root, 2 root 2. Now 2 into root 2. 2 is already rational. 2 is already rational. So you need to, make this one, this irrational factor rational. So it's enough if you multiply and divide by root 2. Now what happens? 1 into root 2 is root 2 divided by 2 root 2 into root 2. Root 2 into root 2 is 2 and 2 into 2 is 4. Root 2 by so now tell me the rationalizing factor of no. Write square root of 243 as a mixed surd. That's the question. Right, express square root of 243 as a mixed surd. That's the question.
Ma'am, 9 root 3.
9 root 3. Yes. That's what. If you find in front of the number, if you have a 1, it's a pure surd. So now you can write not all pure, correct. Not all pure surds can be expressed as mixed surds. Now find the prime factors of 243. So it will be 381 times, 327 times, 9 times, 3 3 is a 3 ones. So square root of 243 can be written as square root of 3 into 3 into 3 into 3 into 3 into 3. Okay. So from 2 3s, 1 3 will come out of the square root. From these 2 3s, 1 3 out of the square root. And one more 3, root 3 remains under the square root. So now 3 3s are 9, 9 root 3. 9 root 3. So this number square root of 243, which is written as a pure surd, can be expressed as a mixed surd. Pure surd because there's 1 in front of it. In front of the irrational factor, there is 1. So it is a pure surd. But this can be expressed as a mixed surd, which is 9 root 3. Because see, you have a 9, you don't have a 1 here. Something other than 1 you have. So it's a mixed surd, 9 root 3. So if this were in the denominator, so supposing you had 2 by square root of 243. So it will be 2 by 9 root 3. So what's the rationalizing factor? Root 3. Just root 3 is a rationalizing factor because 9 is already rational. It's 9 root 3. 9 root 3. 9 is already rational. Rationalization means irrational denominator is made rational. In the denominator, we have 9 root 3, where 9 is already rational. So leave that. Root 3 is irrational. So to rationalize that, it is enough if you multiply and divide by root 3. So this will be 2 divided by 9 root 3. So this will be 2 divided by 9 root 3 into root 3 by root 3. So let's see if the denominator becomes rational. in this process. So multiply the numerators, 2 root 3. Multiply the denominators. What is root 3 into root 3? 3. And into 9, 27. Yeah. The denominator is rational. The denominator is rational. So in our syllabus, rationalization is rationalizing the denominator. There is also this concept of rationalizing the numerator. We are not learning that. In our syllabus, when we say rationalize, default it is rationalize the denominator, not rationalizing the numerator. So I'll just do this again for you. So tell me now quickly, what should you do? If the denominator can be expressed as a mixed surd, you should do that. So square root of 243 is 9 root 3. You know the process. So now this is equal to 2 by 9 root 3 into root 3 by root 3. So it is 2 root 3 divided by 27. Right? So the simplest rationalizing factor is not square root of 243. It is root 3. They'll give you this number. They'll give you this number and they'll give you 4 options. The rationalizing factor of, the question is this, the rationalizing factor of 2 by square root of 243 is, and they'll give you some options. We should not select square root of 243 because it is 9 root 3 and the correct answer is root 3. The rationalizing factor or the simplest rationalizing factor is root 3. Now you will ask me, then if I multiply and divide by square root of 243, am I wrong? You're not wrong. You will then simplify and get this answer 2 root 3 by 27. But that factor you've used in the process, that's not the simplest rationalizing factor. See, it's like, what is the LCM of 10 and 20? 20. But even if you take the LCM as, if you take the common denominator as 60, you will get the answer. The least common multiple of 10 and 20 is 20. The LCM of 10 and 20 is 20. Now, supposing you take the common denominator 60 or 100 or 200, you will get the correct answer. You will get the correct answer. 1 minute, let's just do it. See, if you have to simplify 1 by 10 plus 1 by 20, say, for example. Okay, actually it is common denominator 20, so it will be 2 plus 1, 3 by 20 is the answer. Okay, now what you do is you take the common denominator, say as 200. 200. So what you do into 20 into 20. Here it will be into 10 into 10. So it is 20 plus 10, 30 by 200. Then 0, 0 will get cancelled. So 3 by 20. You're getting the same answer. Even if you take the LCM as not, you can't say LCM. If you take the common denominator as 1000 or some common multiple, you will get the answer. But the LCM is wrong because what is LCM? Least common multiple. The least common multiple is not 200. That is 20. In the same way, you can take square root of 243. You can multiply and divide by square root of 243 and get the correct answer in a few more steps. You will get the answer. But that square root of 243 is not, it's a rationalizing factor, but it is not the simplest rationalizing factor. Like it's 200 is a common multiple, but it's not the least common multiple. In the same way, square root of 243, you can multiply and divide by that. You will get the correct answer. You will have to simplify 2 more extra steps. You'll get the answer, but you have not used you have used the rationalizing factor, but you have not used the simplest rationalizing factor. That's the difference. And you will not get marks. Like if it is a question for 2 marks or 3 marks, you will be awarded marks for the correct answer. But in MCQs, the simplest rationalizing factor. Sometimes the word simplest also will not be there. They'll just ask you the rationalizing factor. You have to select root 3. You have to select root 3. Rationalizing the denominator will always work. Yes. You have to multiply. So when you're given a number with an irrational denominator, you will have to multiply the numerator and denominator by a suitable number, not anything of our choice. You will have to multiply and divide by a suitable number. When you do that, the denominator will be rationalized. The irrational denominator will become rational. Yes, every irrational denominator can be made rational without any exception. So got the idea of rationalizing factor? Okay. It's also called conjugate. All right. Online children, please acknowledge. Can we proceed?
Yes, ma'am.
Yes, ma'am.
Ma'am, I have a doubt.
Yes, Harsha.
Ma'am, can A be minus A?
Yeah. See now, if it is minus root 3, this one you're asking?
Yes, ma'am.
Yes. And now supposing it's minus root 3, minus root 5. So you'll have to take out a minus common. I'll tell you in a question. We'll take a question and I'll tell you. We have questions like that here.
Okay, ma'am.
It can be. You can have a situation like minus root 3, minus root 5.
Yes, ma'am.
Yeah. All right. So the heading is rationalize the denominator in each of the following. All right. Ready? So the first one is, the first number is 1 by, no, we'll understand and then we'll start working. So the first question or the first number is 1 by 3 plus root 2. 1 by 3 plus root 2. Clearly the denominator 3 plus root 2 is irrational. So we have to rationalize the denominator. Now it is 3 plus root 2, like x plus root y. So the rationalizing factor is x minus root y. X minus root y. So 3 minus root 2 is the rationalizing factor. All right. So see, it's very simple. You'll have to just multiply and divide by the conjugate, which is 3 minus root 2. 3 minus root 2. All right. Now multiply the numerators. 1 into anything is the same thing. Multiply the denominators. Denominators are of the form x plus y into x minus y. Okay. 3 plus root 2, 3 minus root 2. So it is x square minus y square. Correct? So it is 3 minus root 2 divided by 3 square is 9 minus root 2 square is 2. So 3 minus root 2 divided by 7. So the irrational denominator has become rational. All right? Yeah. Right on. Take it down, children.
Ma'am, so here I have a doubt.
Yeah.
So if the question instead of this is 1 by 3 minus root 2, then what will be the answer?
You'll have to multiply and divide by 3 plus root 2.
Okay, ma'am, so I need to change the sign.
Correct.
Okay.
Yeah. Don't take down this, children. Not this one. Work this one. Work this.
Ma'am, so just another clarification. If the
Yeah, ask me.
denominator was 3 root 2, then we would have to multiply and divide by root 2.
No, give me the question. 1 by
Instead
3.
of the denominator 3 plus root 2, it is 1 by 3 root 2.
Yeah. Then you need to multiply and divide by root 2.
Okay, ma'am, thank you.
want to come here. இந்த பக்கம். Isa's brother நான் சேவ் பண்ணிடுறேன். உங்க பேர் சொல்லுங்க, ஸ்பெல் பண்ணுங்க. ஸ்பெல் பண்ணி
NUW
M
no miss
N
NUWAID
அப்புறம்
W
how do you pronounce this?
Nuvaid.
Nuved.
Yes, miss.
Then Nuved.
Next WAHID.
Nuved Wahid.
Yes, miss.
Very good. Thank you.
Welcome, yes.
Done, children?
Yes, ma'am.
Yeah. This is the next one. You just do it together and then you can write it in your book. So the given number is 1 by 8 plus 5 root 2. Correct? So the conjugate of the denominator will be 8 minus 5 root 2. Correct. You'll have to multiply and divide by 8 minus 5 root 2. All right. So, see, I've used an equal to sign because we are writing, see, if we are writing an equivalent number, that's all. Like how we used to write equivalent fractions. See, this number is given, no? So to that number, we are multiplying and dividing the same thing. We are writing an equivalent number. See, I've put an equal to sign here. Both are the same. Multiply and divide by a suitable number. And that suitable number is the conjugate, which is 8 minus 5 root 2, right? Now multiply the numerators. So 1 into anything is the same thing. So 8 minus 5 root 2. Denominators, x plus y, x minus y. So x square minus y square. So 8 minus 5 root 2 by 64 minus, what is 5 root 2 the whole square? 5 root 2 into 5 root 2. So 5 into 5, 25. Root 2 and root 2, 50. So 50, which is 8 minus 5 root 2 divided by 14. All right? Yeah. Write down, children.
Done, ma'am.
Yeah. So what's the identity we're using here to multiply the denominators? No, tell me the identity completely. No, tell me the identity in the correct order. Like what is it here? A plus B into A minus B is equal to A square minus B square. Okay, so A plus B into A minus B. This is A plus B, this is A minus B. A plus B into A minus B, the answer is A square minus B square. This is A plus B, this is A minus B. The product is A square minus B square. Yeah. Try this by yourself. Six. Okay. So we have 6 by root 5 plus root 2. The conjugate of the denominator is root 5 minus root 2. So we multiply and divide the number by root 5 minus root 2, right? Now we'll have to multiply the numerators. So here is what is an important thing. Do not write 6 root 5 minus 6 root 2. Don't actually multiply them like this. Write it like the 6 into root 5 minus root 2. I'll tell you why. Don't multiply, just write them in the product form like 6 into root 5 minus root 2. Don't multiply and write the result like 6 into root 5, 6 root 5 minus 6 into root 2, 6 root 2. Don't write it like this. Don't write it like this. Okay, choose to write it like this. Divided by, the denominator is always x plus y into x minus y. So the answer is x square. X square minus y square. Don't multiply. Root 5 minus root 2 divided by root 5 the whole square is 5 minus root 2 the whole square is 2. Next step also, don't multiply. Don't multiply. By 5 minus 2 is 3. Now see your 3 1s are 3 2s are. You can simplify. You can simplify. Now you can multiply. So we have, what do you have actually? 2 into root 5 minus root 2 divided by 1. So this is nothing but 2 root 5 minus 2 root 2. You can leave it like this also. You can leave it as 2 into root 5 minus root 2 also. Or you can multiply and leave it like this. So remember, in the numerator, if you have a factor like this, don't multiply. Don't open the brackets. Just wait till the end. See if you can simplify something from the denominator and this numerator 6. So yeah, here it is possible. So simplify and then you can open the brackets. Right on. Sure. Done, children?
Yes, ma'am.
Okay. Yeah, try this one.
Mom,
Yes.
Mom, I got it as minus root 3 minus root 5.
Minus root 3 minus root
Minus
5.
root
Okay. Perfect. Very good. So first step is to multiply and divide with √3 plus √5, right? Yeah, then multiply the numerator. So 2 into √3 plus √5 divided by x minus y into x plus y. So x square minus y square. As we understood in the earlier answer, do not multiply. Don't open the bracket here. Don't multiply 2 with the terms inside the bracket. Don't multiply. Have the numerator as it is. Simplify the denominator. So this is 3 minus 5. 3 minus 5. √3 the whole square is 3. √5 the whole square is 5. So 3 minus 5. And 3 minus 5 is minus 2, not 2. 3 minus 5 is minus 2. Minus 2. Then you can cancel. My 2 ones are ones are. Right? You can simply cancel the 2's. Correct? So you're left with what? You're left with √3 plus √5 in the numerator and just a minus. That means minus 1 in the denominator. So you need to take that minus up to the numerator. So in the next step, what happens? Take the minus to the numerator. So it will be minus like this. The minus goes up to the numerator. It's a minus 1 in the denominator. Take that minus up to the numerator. So now it will be minus √3 minus √5. When you multiply the minus sign with the terms in the numerator, you get minus √3 minus √5 by 1, which is nothing but minus √3 minus √5. See, there's a minus here. You'll have to take it up to the numerator. The minus will come here. So it will be minus √3 minus into plus minus √5. Finished? Yeah.
Finished, ma'am.
Yeah, very good. Just in case your steps and the steps here don't match, please correct it. Redo if you have not got this answer or your steps don't match with this. Got it? Do this together. So what's a rationalizing factor? Yeah. The denominator is 6 plus 4√3. 6 plus 4√3. So the rationalizing factor is 6 minus 4√3. You can even take out a 2 common. Yeah, you can also do it like this. There's a plus here. So the rationalizing factor is 6 minus 4√3 by 6 minus 4√3. Correct? Now multiply the numerators. Multiply the numerators. See, this is like a minus b into a minus b. Correct? So what is it? A minus b the whole square. 6 minus 4√3 the whole square. The numerators are a minus b into a minus b. So a minus b the whole square divided by denominators x plus y, x minus y. So x square minus y square. X plus y into x minus y is x square minus y square. Now, how do we expand a minus b the whole square? A square minus 2ab plus b square. A square minus 2 into a into b plus b square divided by 6 square is 36 minus 4√3 into 4√3. 4 into 4, 16. Root 3 into root 3, 3. 48. 16 3s are 48. Correct? Then 6 square is 36 minus 2 6 are 12. 12 4s are 48. 2 into 6, 12. 12 4s are 48 root 3. 48 root 3 plus 4 root 3 into 4 root 3. We already computed that. 4 root 3 into 4 root 3 is 48. 48 divided by 36 minus 48. Please. Yeah. Do not cancel 36, 36, 48 and 48. That's not possible because the numbers are separated by a plus or a minus sign. So in the numerator, we have 36 plus 48. You can add them. 36 plus 48. You can add. So 84 minus 48 root 3 divided by minus 12. Divided by minus 12. Now you can take out something common, no? The numerator, what's common? Is 12 common? 12 sevens are 84, right? And 12 fours are 48. So 12 is common in the numerator. So 12 sevens are 84 minus 12 fours are 48 root 3 divided by minus 12. Correct? Yes or no? So minus 12 and minus 12 cancels out. Correct? So that is equal to by minus 1. So we have to take by minus 1. So you'll have to take that minus sign up to the numerator. So it will be minus 7 plus 4 root 3. Plus 4 root 3. Minus 7 plus 4 root 3. You can also work this by taking out 2 common. I worked it like this because here I've worked it like this. You can also do it like this. See here. 6 minus 4 root 3 by 6 plus 4 root 3. What's common actually, children? Here itself, 2 common, right? So you'll have 3 minus 1. Am I not clear? Six minus 4 root 3 by 6 plus 4 root 3. You can also take out 2 straight away common here. So 3 minus 2 root 3 divided by 2 into 3 plus 2 root 3. So you can, correct? So you will multiply and divide with 3 minus 2 root 3 by 3 minus 2 root 3. This working, I'll work and share it on WhatsApp with you. You work it now like this. You can do it like this. You can take out 2 common. If you ask me which is the preferred method, this is the preferred method. Taking out 2 common is the preferred method. But since I have this working in the slide, this is not incorrect, but this is preferred. When you can take out something common, take it out. And the 2 gets cancelled. So the entire number is simplified now. All right? Yeah. Or we'll do one thing. We'll do this together. We'll not do it like this. We'll do it like what I told you in the second place. Yeah, work it with me. Write on the question. Yeah, any questions, children? Online students here? No?
No.
All right. Yeah. See this question. Express 3 by root 3 minus root 2 plus root 5 with a rational denominator. All right. So first what we do is now the denominator has 3 numbers, right? 3 terms. 1, 2, 3. We use brackets appropriately and we convert the denominator to look like having 2 terms. So what we do is we insert a bracket here like this. So see the next step. You can see it here. You can see it here. I've written the given number 3 by, I've inserted a bracket, a simple bracket for the first 2 numbers. So it is root 3 minus root 2 plus root 5. All right. Now it's like this is one term, this is one term, and it's separated by a plus sign. So its conjugate will be write this term, and here this in the denominator here they're separated with a plus sign. So the conjugate will be separated with a minus sign. In the conjugate, the numbers will be separated with a minus sign. Just one second. Yeah, so the denominator is root 3 minus root 2 plus root 5. All right. So insert the bracket for the first 2 numbers. So now this is one term, this is another term, and the terms are separated by a plus sign. So the conjugate of this denominator will be, write the first term. This is the first term. This is the second term. In the denominator, they are separated by a plus sign. So the conjugate, in the conjugate, the numbers will be separated with a minus sign. And you'll have to divide by the same thing. The same thing. Correct? Yeah. Then the numerator becomes what? Don't write. Don't write. Then in the numerator, what happens? It is root 3 minus root 2 minus root 5. You can just put it in one bracket. In the denominator, it is like this is A. This is A. This is B. So this is A plus B, A minus B, A plus B into A minus B. So the product will be A square minus B square, as always. All right. So let's see the working. It's time. So I'll just explain using this itself. Okay. So after inserting brackets and multiplying and dividing by the conjugate, which is the step. So after that, multiply the numerators. So it'll be like this. Multiply the numerators. You can remove the bracket and you can use a bracket like this. See here, in the numerator alone, children, in the numerator alone, after this step, the numerator, you can write it as root 3 minus root 2 minus root 5 all in one bracket. It's the same, no? We just inserted the bracket to write the conjugate. Okay, so now in the numerator, you can just take off the brackets and use it like this. In the numerator. So it will be 3 and in bracket, see this numerator into this numerator will be 3 into all this. That's what you see here. This number 3 into all this in one bracket divided by this is A plus B, A minus B. So A square. This is A square. What is A? Root 3 minus root 2 is A. Root 3 minus root 2 is A square minus what is B? Root 5, the whole square. See here, the difference is this one is A. This is B. This is A, this is B. A plus B into A minus B. This is A square minus B square minus B square. Now don't multiply. We have seen this earlier. Don't multiply. Don't write the numerator as 3 root 3 minus 3 root 2 minus 3 root 5. Don't do that. Okay. So we'll wait till the end. We'll write the numerator. We'll carry the numerator as it is. We'll not multiply this 3 with the terms inside the bracket. In the denominator, A square minus B square, right? So how do you simplify this one? This itself is like A minus B the whole square. This A square itself is A minus B the whole square. So you can see here A square plus B square minus 2AB. And minus root 5 the whole square is minus 5. In the denominator, this itself is like A minus B the whole square. So it's A square plus B square minus 2AB. And minus root 5 the whole square is 5, minus 5. Look at the board. Okay, write the numerator as it is. And what is root 3 the whole square? 3. What is root 2 the whole square? 2. And here the product, root 3 into root 2 is root 6. So 2 root 6 minus 2 root 6. And minus 5. This minus 5. Now simplify. So 3 plus 2, 5. 5 minus 2 root 6 and this minus 5. 3 plus 2 is 5 minus 2 root 6 and this minus 5. Correct? Now this plus 5 and minus 5 in the denominator gets cancelled. 5 and minus 5 gets cancelled. So we are left with minus 2 root 6. Minus 2 root 6. Okay, so the denominator was like this. Now after this process, it looks like this. However, it is still irrational. Where are we now? From this denominator, see, like, let's see here. 5 and minus 5 gets cancelled. So from this denominator, we've brought it to this denominator, minus 2 root 6. Still, the denominator is irrational. It's not rational. So you'll have to proceed. You'll have to still perform some procedure and make that irrational denominator rational. It looks simpler now, that's all. So now what should you do? What's the rationalizing factor? Root 6. Root 6. Because minus 2 is already rational. In minus 2 root 6, you can look at minus 2 and root 6 separately. They are two different numbers. All right. All right. So minus 2 is already rational. Leave that. So root 6. Multiply and divide by root 6. Correct? Okay. So this 3. Can you see the 3 here? Yeah. Now multiply this root 6. Root 3 into root 6 will be root of 3 into 6. See, we need to multiply. This 3, I've written it as it is here. We need to multiply this root 6 with these numbers in the numerator. So how do you do that? Root 3 into root 6 is root of 3 into 6. Root 2 into root 6, root of 2 into 6. Root 5 into root 6, root of 5 into 6. Divided by, multiply this and this. So minus 2 root 6 into root 6. Root 6 into root 6 is 6. Minus 2 into 6, minus 12. Okay, I've cancelled. So, okay, anyways, the value is minus 12. We have understood that. All right. So what I've done is I've just written this minus 2 and this root 6 into root 6 is 6. I've simplified. 3 1s are 3 2s are. You understood this multiplication, children? Multiplying root 6 with everything here. Okay, so that's the numerator. This 3 is here. And in the denominator, minus 2, you can see it here. Root 6 into root 6 is 6. Now you can simplify. There's a 3 here, right? So 3 1s are, 3 2s are. Correct? Now here, factorize further. What is 6? 3 into 2. So you can see this 3 here. And the 6 is written as 3 into 2. And the 6 is written as 2 into 3 or 3 into 2, whatever. And you can see this 2 here. And here this 5 and 6 is written as 3 into 2. So 3 is gone, children, because 3 1s are, 3 2s are. The 3 is gone. Okay, so in the numerator, you have only this. Now, next step, from 2 3s, 1 3 out of the square root. This root 2 remains under the square root. From 2 2's, 1 2 out of the square root, 3 remains under the square root, root 3. And here, no pairs of equal factors. There's only 1 5, 1 3, and 1 2. So you'll have to multiply them back. So 5 3s are 15, 2s are 30, root 30. All right? By minus 4. By minus 4. Now take the minus. Always when you have the minus sign in the denominator, take it up to the numerator. Always when you have the minus sign, okay, take it up to the numerator. So put the minus. See, this minus alone goes to the numerator. Minus. Minus. The 4 remains in the denominator. 4 is there. 4 is here. The minus alone goes to the numerator. All right. So it becomes minus. It becomes. I've just written the positive terms first. See this one, when you multiply the minus sign, it will become minus 3 root 2, right? So I've not written the negative term first. I've just written it here. I've changed the order. I haven't started with the negative term. That's all it is. You can write it also. I've just changed the order. So you can see here minus 3 root 2. You can see it here minus 3 root 2. Minus into minus 2 root 3 is plus 2 root 3. You can see here plus 2 root 3. And minus into minus root 30 is plus root 30 here. I've just changed the order. I've just put this negative term in the end. That's all. By 4. Now see, look at the denominator 4. It's rational. So when we have 3 numbers like this in the denominator connected by a plus or minus sign, or we have to do that rationalizing procedure 2 times. Once when you multiply and divide, it becomes simple, but it is not rational. Again, you'll have to perform it so that the denominator is completely rational. All right. All right, children. Online children and children here. That's it for today's session. Thank you so much. Good night. Online children can leave the call. I'll share the answer, the picture on WhatsApp. You can complete it before the next class. Thank you, children.
Thank you.
Thank you, children. Good night.